So we just looked at this experiment and we saw that, hey, in this smiley face group of tables, they seem to give tips kind of in this like 20 to 60-ish range, um, while the control condition is really more clustered in that 20 to 40 range, right? And so you could think about these two as kind of a shift, right? And so, I mean, if you asked me, hey, predict the tips of this table, and I'll tell you they were in the smiley face group, I might predict that they might have a slightly higher tip than the control condition, even though in a lot of ways these two distributions pretty much look similar too. Now, that's just our sample. In our sample, condition might be helpful for us to make a prediction about their tips. But is that true in the DGP or population? The data generating process is kind of this process that we're really interested in. You know, when people are deciding on how much of a tip to give, is smiley face somehow part of that data generating process, right? Is it like in their little minds, they're kind of somehow taking into account smiley face and that's kind of making them give a bigger tip? That's one exciting theory that we might have. But obviously, smiley face isn't the only thing that influences tips. There might be other stuff too. So we leave other stuff, things like how much food did they buy and how nice was the service, right? So this is one theory of our DGP. Now, do we know if that theory is true based on our data? No. I mean, this is just our data. This is what we want to know. But one of the things that the shuffle exercise taught us was that even if there was nothing different about these two groups, maybe they were just randomly shuffled into two different groups, we would have come up with two slightly different distributions. So that is the problem of type 1 error. And we really talk about it as this other data generating process that could be involved. Maybe smiley face doesn't have anything to do with it. Maybe the data generating process is just randomness, right? Maybe these two groups are just randomly different from each other. And here's what we mean by randomness. Maybe it's that if I had this table that gave like 60 something dollars as their tip, that group could have had an equal chance of ending up in the smiley face group or the control condition, right? And in this particular case, that group, that table ended up in the smiley face condition, but maybe in another experiment, they could have ended up in the control condition, right? So that's really this idea that, hey, this data, this pattern of data could have been generated from just randomness, which is a process that does not have smiley face involved at all. Now, the nice thing about R is that we could actually generate data using a random process, such as shuffle. And so when we shuffle condition, what we do is we randomly place each of these tip values into one of these two conditions, right? And so let's take a look at this one, for example. Here, these two very big tips ended up in the control condition and not in the smiley face condition. But if you take a look at this set of data generated from shuffle, one of those tips ended up in the control condition, but the other big tip, really big tip, ended up in the smiley face condition. In each of these sets of data, we ended up with two slightly different groups, a control group and a smiley face group. But we know that the difference between these groups is not caused by smiley face, it's caused by shuffle, us just shuffling these conditions around. Now, why do we do this? Well, the big question is, we don't know how this sample was created. We know how these samples were created. We know that they were created by shuffling. And so we call these simulated samples rather than the real sample. And what we want to know is, hey, is this real sample? Does it look like these or not? Right? Let's say that the sample does not look like these, right? If the sample does not look like these, and we know that these were made from this process, this data generating process, we might say, oh, this sample is really different from these brethren. And so instead, we're going to rule out randomness as the possible data generating process that generated this sample. And so when we rule that out, it kind of gives some space for this theory to become a contender. Now, we don't know for sure that smiley face still had anything to do with it, but because we could rule out randomness, we could start to consider other data generating processes, such as smiley face being involved. Now, what if the sample looks basically just like all of these guys, right? Then we might say, hey, we know that randomness created all of these guys, and this one looks just like all of these guys, so maybe randomness also generated the sample as well. And so we might say, hey, randomness is not a bad data theory for our data generating process. At this point, you might be asking, well, how do you decide whether the sample looks like these shuffled samples or not, right? It seems like a lot rides on that judgment. Well, for right now, we're actually just eyeballing it. And eyeballing it is really hard because it's really hard to see whether this looks very different from these or not, right? And so later on, as we move into chapter 7, 8, 9, 10, and 11, we'll actually be talking more about how to quantify that difference. But for now, I want to give you a bit of an intuition. Let's say that instead of our actual sample looking like this, maybe our sample actually looked like this, where basically if you were in the control condition, those tables gave around, 10 to 25 or $30 worth of tips. And if you were in the smiley face condition, nobody gave $20 gift tips. Instead, they gave like 30 to, 60 something dollar tips. In this case, you would see, wow, there's a really big difference between the control group and the smiley face group. These distributions look super different from each other, right? But in these shuffled ones, there's a lot more overlap, right? So these are just the same as these, right? These overlap with these, right? But here, these don't overlap with these at all. See? There are almost no tips that are like that in this condition. And here, there are almost no tips that are like that in this condition, right? Now let's think about how we would get a pattern of data like that through randomness. In order to get a pattern like that through shuffling, we would have had to randomly shuffle all the low scores into the control group and randomly shuffle all the high scores into the smiley face group. Now, that's possible. It's possible, but it's not likely. It's very hard to shuffle this pattern of data. Most shuffles look like this kind of pattern of data, where some of the high tips end up in this condition, and some of the high tips end up in this condition. Some of the low tips end up in this condition. Some of the low tips end up in this condition. And so that's just to give you a flavor for what we mean by comparing the sample to these shuffled data. And if this was our sample, then we might look at these shuffled data and say, wow, randomness really does not look like it could have produced this. It's not likely to anyway. And because of that, we might rule out randomness and say, oh, I think smiley face definitely had something to do with it. Would we be correct? I don't know. We might be wrong. That's why we always have to stay humble and tell ourselves, hey, there's always the possibility of type 1 error.